Good morning, 7th graders. All right, so the last assignment you should have done, if you're up to date, caught up, is this page on the right here. And yes, this is the answer key. Oh, I'm giving you the answer key, but really, these answers are all right on Quizlet, so hopefully you didn't have a hard time filling these out. I'm just going to keep this up here with our vocab so we can talk about them as we fill out this next page in our notes, where we're going to practice some Punnet squares, which is a model that we use when we talk about genetics and dominant versus recessive alleles. So what are alleles? If we look over here at our notes, you'll see that alleles are different forms of a gene. For example, this is the first example we do. There are lots of different genes for eye color. And eye color is actually a lot more complicated because there's so many different genes. It's not a gene where there's only two different alleles, but typically when we first start off looking at genetics, we'll look at the brown eye gene and the blue eye gene. And brown eyes are dominant to blue eyes. So what does that mean if we look here at our vocab for dominant allele? It says an allele whose trait always shows up in the organism when the allele is present. So whether there's only one of that allele or there's two of that allele, it's still going to show up the dominant trait. And we're going to look at that here in a second, and I'll show you an example. So I'm going to go ahead and start writing on this page on the left, our Punnet square practice. Maybe if it'll let me. Okay, so let's zoom in a little. All right, so first we're going to look at brown eyes and blue eyes, like I said. All right, so actually let me just use brown. That might make this easier. If it'll let me. Oh my goodness. Do you guys feel like you're back in class watching me struggle with the smartboard? Let's try my mouse. It still doesn't want to let me. Okay, let's open this page big. We can go back to that later. What on earth? Guess we're not using brown. I was going to change the marker to brown and blue, but guess that's not happening. Okay, so when we look at a square, this is kind of like if you guys have done like a multiplication table type of thing, or really anything where it's set up like this. So for this first square, I'm looking at this one, we're going to look at the letter to the left and the letter above it. Okay, so in this case, and these squares represent possible offspring, like possible combinations of genes. So this would be if they had one parent that had both blue-eye genes, and we always use that lowercase letter to represent the recessive gene. And then we had one parent that had both dominant genes, both brown-eye genes. All right, so this box right here represents a 25% chance of getting an offspring that has one of each. All right, which we know that having one of each means the dominant one's going to show up. All right, so this child, even though they have both genes, would have brown eyes, and they would just carry the blue-eye gene. All right, and then same for this child, and for this child, and for this child. All right, these are all the same because, let's say the one on top is dad. Dad has blue eyes, he has both blue-eye genes. Mom has brown eyes, she has both brown-eye genes. That means dad can only give the blue-eye gene, mom can only give the brown-eye gene, which means that all the offspring are going to get one brown-eyed gene from mom and one blue-eyed gene from dad. So they're all going to be one of each, which our fancy science word for that is heterozygous. All right, if you remember, we've talked about these prefixes before. Hetero means different, so they have two different genes. And so let's go down here and look at the probability, what kind of dominance. So this is called regular dominance. All right, so regular dominance, when the dominant allele is present, it takes over, it masks the other one. So all of these kids, even though they have one of each gene, they will all have regular brown eyes, right? They're not going to have a weird mixture. They're not going to have brown with blue spots. They just have brown eyes. in this example. And yes, some of you might have eyes with different spotted colors in them, or they change colors or something. And that's because in real life, the eye color gene is much more complicated, and there's many more alleles than just brown eye and blue eye, but that's not what we're getting into right now, so don't worry about that. So offspring probability, all 4 of these representative offspring are heterozygous, so they'll have brown eyes, which means there's an 100% chance that this mom and dad will have brown eye babies, and a 0% chance for them to have blue eye babies. All right, because to have blue eye babies, to have blue eyes, you have to have, in this scenario, both recessive genes, and mom over here doesn't have any recessive genes to give, so none of their children will have blue eyes. Okay, sorry guys. Whew. Okay, so we're going to do the same thing over here. We look to the left, look up. This offspring box gets 2 big B's, 2 capitals. This one also gets 2 capitals. This one gets 1 of each, and this one gets 1 of each. And it's proper form to always write the capital letter first when we do heterozygous, so you wouldn't write it like this. All right, so just like a sentence, think of that. If that helps, think of it that way. Capital letter is first. All right, so I don't have the box here for what kind of dominance because it's the same as this one. All right, but brown eyes. So if we look at this, even though we have some homozygous dominant, right? So remember we said that the prefix homo means same. So they have, these 2 are homozygous dominant, meaning that they have homozygous, meaning they have 2 of the same allele. Dominant, meaning that allele is the dominant one, or the capital letter. So those 2 will have brown eyes. But these 2 will also have brown eyes because they're heterozygous. So the dominant one wins out, just like all the offspring in our last one. So this set of parents still has an 100% chance of brown eyes and a 0% chance of blue eyes. If you're still writing that down, pause it. I'm going to go ahead and scroll. And I really wish this would let me change colors. This is making me very sad. I don't know. Okay. I wonder what would happen if I did this. This is super annoying. Okay, I'm going to move on. I really wanted to write different colors. Oh well. All right, so we're going to do the same thing here, but we have 2 different genes. So this yellow box looking at here, we're looking at lizards and their skin color allele, skin color genes. So it shows you there's 3 different phenotypes that can happen here. So if you remember from our vocab, phenotype means the physical appearance. So we always have 3 genotypes, which is 2 of the same dominant, 2 of the same recessive, or in this case, other dominant. So you can see these are all capitals, this G and these Y's, and then the mixture, right? So 2 of one, 2 of the other, or a mixture. But in this case, we actually have 3 different phenotypes. Phenotypes is the physical appearance, whereas up here with this eye gene that we looked at, again, real eye gene, much more complicated, but this example, we only had 2 phenotype options, brown eyes or blue eyes. So in this one, we're going to have 3 options. All right, but let's go ahead and fill out our Punnet square like normal. Oopsies. All right, so what kind of dominance is this? This is called codominance. When there's 2 dominant genes, codominance. Sorry, I was sounding it out. Oh well. So there's 2 dominants and they're going to work together here. They're kind of going to share when they're both present, like in these, both dominant genes are present. They're going to kind of share what's happening here. They're going to both show up. Okay, they work together, they both show up. So these 2 that are both capital G's, those are obviously going to be just green. So there's 50% green. All right, we don't have any offspring boxes that have 2 Y's. So they're 0% yellow. So what's going to happen with this green-yellow box? These GYs, they're going to be green and yellow. So some sort of pattern where it's like maybe spotted or maybe just mixed, like, but you're going to see green and yellow, not a mixture, not like one color that's kind of like green-yellow, like that weird green-yellow crayon, but you're going to see, clearly be able to see the green and also be able to see the yellow. And so that will be 50%. All right, pause that if you're still, I guess you don't have to pause it, but I'm going to go on to the roses. All right, so this rose color that we're going to look at, I'm just going to tell you right now, it's called incomplete dominance. All right, that is sloppy, but incomplete. This says incomplete. Okay. So let's go ahead and fill out the Punnet square. We look left, we look up and see what alleles we get from mom and dad. Okay, so here we have two heterozygous parents, right? So both parents have one of each allele. If this had happened with our brown-eyed, blue-eyed parents up top, this box here that has two lowercase letters would have been a blue-eyed baby. Or I guess it represents a 25% chance of having a blue-eyed baby. But this is not regular dominance. This is incomplete dominance. So something a little bit different is going to happen here. So red is the dominant allele. So this one that's 2 R's is going to represent red. All right, and then these homozygous ones, not homozygous, sorry, these two heterozygous ones, these two that have one of each, the red is not fully dominant, which means when there's only one red allele, it's going to show up a little bit, but not all the way. So it's going to kind of blend. Okay, so they're going to result in pink. So those two each represent a 25% chance, which means total there's a 50% chance of having a pink phenotype or a pink physical appearance. And I believe in our notes, I guess I'll go look. I even underlined, that's not it, it's calculus, you guys don't want that. There it is. I underlined the pH and phenotype right there, look at that. And that was to help you remember that it's physical appearance, right? Phenotype is the physical appearance. Oh, look, and I even put the dominance in here, right? So regular dominance, only one dominant allele needed to be present in order to override the recessive allele. Codominance, when both alleles for a gene are dominant and fully expressed, like our lizard, where you could see the green and see the yellow. It's not blended, you can see them both clearly. And then what we're doing right now, incomplete dominance, when neither allele is fully dominant. So the heterozygous genotype, or aka heterozygous, hetero means different. So the genotype, when there's two different alleles, results in a blended phenotype, which is what we're doing with our roses right here. All right, so then our last square to look at, the two little r's, that would be when there's no red allele showing up. So those are going to result in white roses, and so that'll be a 25% chance. All right, and when we're working with percentages here, remember they should always add up to 100. So here, 25 plus 25 is 50, plus another 50 is 100. Over here at the lizards, 50 plus 50 is 100. And then up here, they all add up to 100. So if you are doing probability with Punnet squares, make sure that they always add up to 100. If they don't, you might have done something wrong. And I don't know if it was in your guys' class or not, but someone, I think it was in one of my other classes, asked about this a different time. And so I'm going to just tell you now because so I don't have to hear about it. The reason this says 2019 at the bottom, I know it's 2020. It's because I made this activity in 2019. So that's why it says that, in case you care. Okay, I think that is all our notes for today. It is, isn't it? All right, so don't be overwhelmed. I know this is a new concept and you might be like, what the heck just happened? Feel free to watch the video again. Feel free to print out the paper and write it down on paper if that helps you. And then you can also have notes to keep, which is never a bad idea. Or you can just fill it out on the Google Doc if you're comfortable with that. Whatever you need to do, but you can watch the video more than once. And also we can talk about it during our class meeting tomorrow. Or I guess I don't know what day I'll be watching this, but during our class meeting on Wednesday, if you guys need help still. All right. So hopefully now you have those notes filled out, and hopefully before you watched this, you had the vocab already filled out. All right. This vocab is on Quizlet, which you should know because that should be where you get your answers from. So feel free to start practicing that if you feel like you're already confused. But our next activity for genetics is going to be something a little bit more fun, and I'm very excited about it. It's one of my favorite things to do with my classes. My class last year loved it. I loved it, so I'm excited, and stay tuned. All right, bye guys. Have a good day.